Hi class, for today's video lecture we're going to be talking about hypotheses, specifically how to write hypotheses, and more specifically how to write what we're going to call formal hypotheses. You know what, let me change my pen a little bit, make it a little bit better here. Formal hypotheses, that's what we're looking at today. And so we're going to learn how to write hypotheses and the criteria by which I will be grading you when you write your hypotheses. Later in the lecture we'll be troubleshooting. That is to say, we'll be fixing hypotheses or fixing common mistakes that I often find when students write or compose hypotheses. So let's take a look. First things first, let's define what a hypothesis really is. So many times I ask students, especially underclassmen, what a hypothesis is, and I get answers like, oh, it's a guess. Or it's an educated guess, some people will say, which is actually closer to the truth. It is educated, but I wouldn't describe a hypothesis as a guess. It is not a guess. It is not as if you're hoping for something to happen. It is some kind of prediction. And when we say the word prediction, we are talking about an expectation. And that expectation is founded in fact and observation. So using what you already know about the issue, using what you already know about an experiment or some kind of concept, now you can make a prediction. And it's not just any prediction, but it is a prediction of a relationship. How two variables, how two things that can change, how they are related to one another. So that is to say, when I talk about a relationship, if two things are related and I increase variable 1, what will happen to variable 2? Will it increase or will it decrease? So that's really those are the relationships that we are talking about. Those are the predictions we are talking about. If I increase something, one variable, what will happen, what will you predict will happen to a second variable? All right, and we're going to talk all about that. So a hypothesis is a predicted relationship between two variables, and it is founded. There is background information. It is founded on established fact and observation, what you already know or what other scientists already know and have published. All right, in my class, when we write hypotheses, and many of you should already know this, there are going to be 3 elements to a quality formal hypothesis. Those elements are that the hypothesis is in an if-then format. You're going to say if one thing is true, then the prediction. Okay, if something occurs, then something else will occur, or something else will change. The second quality, or the second element, is that you will identify two variables, and that you'll identify them in the if portion of your hypothesis. So that is to say, you're going to say, if variable 1 is related, so you're going to say that there is a relationship, if variable 1 is related to variable 2, comma. Easy, right? Easy. If variable 1 is related to variable 2, then, so that means you've got your if-then you're going to create a prediction. And not just any prediction, a prediction of a trend. That is to say, you're creating a hypothesis. All right, the prediction of a trend between two variables. And we already talked about how we describe relationships of trends. All right, you're going to say if variable 1 is related to variable 2, then an increase in variable 1 will result, if I can fit this, in, let's say, a decrease in variable 2. I've just described a trend. That is really one of the main formats of a hypothesis that you're going to be writing here. If variable 1 is related to variable 2, then an increase in variable 1 will result in a decrease in variable 2. You might equally validly, you might say an increase in variable 1 will result in an increase in variable 2. All right, so it's not rocket science here, but those are formal hypotheses, and that's what I'm looking for in the introduction of any of your lab reports. And anytime I ask for a hypothesis, and anytime on an AP exam it asks for you to generate or to design an experiment, you're going to be involving a hypothesis, and you're going to want to write your hypothesis like this. So let's take a look at some examples, and then let's start to troubleshoot and try to edit and fix some errors here. These are two examples of quality hypotheses that satisfy the criteria, satisfy those three elements. So let's take a look. If the hours of sleep, I'm going to underline hours of sleep because that's one variable. Let's call that variable 1. If the hours of sleep is related to the number of annual colds contracted, then the more sleep will result in fewer colds contracted. Now, I probably could have worded that a little bit better, but the point is clear. We've got if variable 1 is related to variable 2, then we have a prediction. Then an increase in sleep will result in a decrease in colds. That sort of makes sense, given what we know about sleep, given what we know about disease and colds and viruses in our immune system. Right? This hypothesis is not just a wild guess. It's based in fact, it's based in observation, it's based in what we already know. All right? And it's based in really what has been published in the scientific world. Let's take a look at a second example. If the number of bananas in my kitchen is related to the number of fruit flies in my kitchen, then an increase in bananas will result in an increase in fruit flies. Okay, again, if variable 1 is related to variable 2, then we see a relationship between, and that relationship is a trend. Okay, so let's talk quickly about these relationships. In example 1, we see a relationship in which an increase in one variable results in a decrease in the second variable. We call that an inverse relationship. Okay, that's an inverse relationship. Make a note of that. Because when I ask you what kind of prediction you're making, you'll say, oh, I predict an inverse relationship between these two variables. Whereas hypothesis 2, on the other hand, predicts that an increase in variable 1 will result in an increase in variable 2. We call that a direct relationship. So if I asked you what kind of relationship you might predict or what kind of trend you might predict, you would say something to the effect that I predict a direct trend between these two variables. Okay? So we've got two very good hypotheses. Let's take a look at other hypotheses that are less good, and we can try to fix them. All right, let's take a quick read. If the number of calories consumed daily is related to weight gain, then a change in calories consumed will result in a change in weight gain. This is a common error that I see oftentimes when students write hypotheses. Why don't you pause the video, think for a second, and try to make a change to this hypothesis to make it a little bit better. Okay, so hopefully you've paused and have made a change to this hypothesis. The way I would change it, for example, is if the number of calories consumed daily is related to weight gain, then a decrease in calories will result in a decrease in weight gain. What we saw in the previous less good hypothesis is that the student may have said that a change in variable 1 will result in a change in variable 2. Well, that might be true, but they haven't indicated what kind of change will result in what kind of change. They haven't given me indication of a direct or indirect or inverse relationship. I need to know, is it direct, is it inverse? All right, so my change, the change that I instituted, indicates a direct relationship or a prediction of a direct relationship. Because if you don't indicate one kind of relationship or another kind of relationship, then you can't be proven wrong and your hypothesis isn't really testable. And that's really one of the main criteria of any hypothesis. It has to be testable. It has to be proven right or proven wrong, one way or another. And let's be clear here. It's not bad that a hypothesis has been proven wrong. It's not bad at all. In fact, it's good that it can be proven wrong, because after you perform your test, prove your hypothesis wrong, and make a conclusion, now you revise your hypothesis and retest. And that's all it is. That's what science is. It's not an opportunity to be right or wrong. It's just an opportunity to validate or invalidate a hypothesis. Let's just start thinking about science that way. Here's another example. If you consume more salt, then your blood pressure will increase. Ask yourself first this question. Does it satisfy the 3 elements or the 3 criteria of a formal hypothesis? Pause the video and then think about it. All right, let's think. Does it have an if-then? I think it does. It's got an if, it's got a then. Does it indicate 2 variables related to one another? If you consume more salt, well, it doesn't indicate a relationship between 2 variables. It says more salt, so salt would be one variable, or consumption of salt is one variable. But the process or the phrase in right after the if part of my hypothesis doesn't indicate 2 variables. I only see 1 variable. So that's not a very that doesn't meet that criteria. Okay, so I would change that. And then it says, then your blood pressure will increase. Well, it does indicate then a prediction. It says more of one thing will result in a decrease, or, excuse me, an increase in a second thing. Okay, so it does give a prediction. So it satisfies number 1, it does not satisfy number 2, and satisfies number 3. Let's try to make a change here. So I've fixed it. I said if salt consumption, my first variable, is related to blood pressure, my second variable, then an increase in salt consumption will result in a decrease in blood pressure. That's my prediction, a prediction of an inverse relationship. All right, that's a quick and easy way of fixing this particular hypothesis. Let's look at one more. All right, this one looks like it needs quite a bit of work. Okay, it says the more books read will make you smarter. All right, think a little bit about how to make this hypothesis a quality hypothesis, a quality formal hypothesis. Pause the video, take a second to think. Okay, hopefully you've thought a little bit. Ask yourself, does it have an if-then? No, it does not. Does it indicate a relationship between 2 variables? Well, we sort of see books read and smarter, or maybe intelligence, or something like that. But it doesn't really indicate, I'm going to say maybe. That's almost, or it's approximate. But I'm almost trending toward no. And does it have a prediction of a trend? The more books read will make you smarter? Yeah, sort of, yeah. The more books will make you more smart. I can see some kind of direct relationship there. But if we really want to make this like a formal hypothesis, it's going to take some work. So let's pick apart this one more time. The real problem with this hypothesis is this. Smartness, in many ways, is very difficult to test. Is it testable? Can you quantify smartness? If so, how will you do so? Okay, that's really I'd say the fundamental problem with this hypothesis. And it's a difficult and a subtle problem. How do you test, how do you measure smartness? Is it a score on a test? And how do we know that means smartness? So let's take a look at how I fixed this. Here's my correction. If the number of annual books read is related to the size of your vocabulary, so the number of annual books read, notice that it's annual, just for the heck of it, is related to the size of my vocabulary, as I almost cross vocabulary out. All right, I'm sort of equating vocabulary size with intelligence. I'd say if you know more words and if you can use them, then let's say I would argue that you might be smarter. And maybe it's an arbitrary distinction, but maybe I've read a particular study that says people who know lots of words have higher IQs, for example. And so if I say if the number of annual books read is related to the size of your vocabulary, I can quantify that. I can quantify how many books you read every year, and I can quantify using various methods how big your vocabulary is and how big your working vocabulary is. So there we go. I've generated a second variable that's actually quantifiable, that can be measured. Quantifiable, if I can spell it. It can be measured, right? That's really the issue with the original hypothesis, and that's what I wanted to get at with this one. So if the number of annual books read is related to the size of vocabulary, my prediction is then an increase in books read annually will result in an increase in vocabulary size, which is in fact why we institute the reading period here at Salesian. All right, so what we're going to do now is that we're going to talk about these variables that we've identified. Okay, we keep talking about these two variables, variable 1 and variable 2. We're going to be talking about them more specifically now. First of all, let's break apart the word variable. What does variable mean? Well, what does it mean to vary something? Well, to vary something means to change it. Okay? And so when we say a variable, we're saying that it is something that can change and usually change quantity, because we really want to be able to measure something and use numbers to do so, because that's a lot easier and more straightforward to communicate relatedness. Okay, so when we say a variable, it's something that can change quantity, and we're going to identify two kinds of variables, really: independent variables and dependent variables. We may or may not have already looked at what these words mean, but we're going to do so again. So let's take a look. Here we go, independent variable. An independent variable is what we're going to call the manipulated variable. Okay, when I say manipulated, it's the variable that the scientist, or that you, as the scientist, have direct control over. You can control this. You can add to it, you can make it bigger, or you can make it smaller. You have direct control. It is the manipulated one. It is the one that you can manipulate. Okay? When we talked about graphing, we said that the manipulated variable, or the independent variable, goes on the x-axis. And so we remember the acronym MIX, M-I-X, for the manipulated, independent, and x-axis. On the other hand, the dependent variable is the one that depends on the independent variable. It is the responding variable. All right? It is the variable that changes as a result. That is to say, it depends on the independent variable. Okay? It changes just like the independent variable changes, but you don't change the you don't change the dependent variable. The dependent variable changes because of a change to the independent variable. Okay? So that's a very important distinction. So whatever thing that is changing because of the change in the independent variable, that would be the dependent variable. So the dependent variable is the responding variable, which goes on the y-axis, which is why we're going to remember the acronym DRY. And so if we can remember DRY and MIX, we're going to be graphing our data like pros. So importantly, what we want to do when we're writing hypotheses is we want to be able to write a hypothesis with a very specific identification of our variables, of our independent variable and our dependent variable. So let's try to identify them. And we're going to identify the independent variable in red, and we're going to identify the dependent variable in blue. Okay? So I'm just going to circle or underline those. So let's take a look. If the hours of sleep is related to the number of annual colds contracted, then more sleep will result in fewer colds contracted. Keep in mind, this is one of the hypotheses we took a look at previously. So what can I control here? That is to say, what is the independent variable? What can I manipulate? Well, I can manipulate how many hours of sleep I sleep. I can sleep longer, or I can wake myself up earlier. I have direct control over the number of or the hours of sleep I sleep per night. As a result, because of how much sleep I have, I might contract more colds. I might contract fewer colds. If I sleep more, if I control my sleep and I sleep more, then I would likely have fewer colds. That is a result of my sleep. So the colds contracted would be the dependent variable. Let's take a look at the second hypothesis. If the number of bananas in my kitchen is related to the number of fruit flies in my kitchen, then an increase in bananas will result in an increase in fruit flies. So I can buy more bananas, or I don't have to buy any bananas. So I control the number of bananas, and the number of fruit flies depends on the number of bananas in my house. If there are no bananas, there are no fruit flies. So the number of bananas would be the dependent variable. All right, let's do this really quickly. If the number of calories consumed daily is related to weight gain, then a decrease in calories consumed will result in a decrease in weight gain. Think about it for a second on your own. Clearly, we know I can control how many calories I eat per day. And as a result, because or depending on the calories, my weight will gain or loss, or my weight gain will increase or decrease. Depending on calories. So we got a dependent variable. If salt consumption is related to blood pressure, so I can consume salt, or I don't have to consume salt, I can cut it out of my diet. And as a result, because of my salt consumption, my blood pressure will increase or decrease. Are we seeing a pattern here? We typically see our independent variable written first in our hypothesis. Okay, so if the number of annual books read, if I draw that in red, okay, I'm saying it's the independent variable. Let's evaluate. Can I change the number of books I read? Yes, absolutely I can. I can read a lot of books, or I read no books, or anywhere anywhere in between. And as a result, depending on how many books I read, my vocabulary size will change. It will increase or it will decrease. Okay. So hopefully this lecture gives you a better idea of what we're talking about when I say writing hypotheses. You'll have a worksheet to complete that asks you to do the same. Okay. Again, we're looking for an if-then, two variables related to one another, and a prediction that predicts a trend. All right. If you have any questions, let me know. All right. Good luck and take care.